you like the phone, you will buy the product. So you will buy the product. Once you when you buy the product, means what happens is that he will ask you to fill up a form. Then you will get the product, you will get a bill, and you make a payment, right? This is this entire steps of from the time you go to a client to the shop, make an inquiry, till the time you make the payment to the stores. That is a business process, right? Now, if I want to look it from an industry perspective, so if I'm in Hindustan Livers and I am a customer, so Hindustan Liver is going to sell me some soaps, and Hindustan Livers, when it comes to me, he will tell me about the soap, he will give me the price, and I decide to buy the soap. So in that case, what Hindustan Liver does, it will, once it gives me the quotation, then it will then what will happen is I will give, that means I as a customer will give a purchase order. The customer will give a purchase order. Please forego my spelling mistake, just focus on the contents. So customer will give a PO, purchase order. Then what I will do, when customer gives a PO, then Hindustan Levers, what they will do is they will deliver the product. Okay. When they will deliver the product to me as a customer, then I will acknowledge that I have received the product. Okay, that the product is received. Okay. So once the product is received by me, then Hindustan Levers will raise an invoice. We all call it bill in normal terms. Bill will raise an invoice, and when they raise an invoice to me, to the customer, and then the customer will make a payment. Makes a payment. Now, this complete process, right from the purchase order the customer gives till the time the customer makes the payment, in an industry term, this is called order to cash process. Now, when I'm talking of automation of business processes, out of these steps, there could be some of the steps which could be done automatically by some tools or by some machine, right? So that the time taken to process, suppose a normal time takes around 2 hours to do an end-to-end process, order to cash process. Using some automation, while I automate some of the steps, I can reduce the time to maybe even 10 minutes, 15 minutes, 30 minutes, and so on. So today there are tools, RPA tools like Automation Anywhere, Prism, which takes care of automation. Okay, so they are called RPA tools, robotic process automation tools. Okay. Then as the data has become more complex, number of data has increased, you have got non-text data like images, which needs to be which needs to be predicted. Now you need to have machines which can predict even an image, whether I can say whether this an image is a cat or this image is a dog. Okay, so today I have neural networks. These are called deep, as part of deep learning architecture, which is, so I have got neural networks which help me to process very complex data, various images, and help me to predict. Okay, based through these neural networks, it will help me to predict a new image. Okay, so you have artificial neural networks, you have convolutional neural networks, which are typically used for capturing images, processing images, and prediction of images, right, for new set of data. Then you also have what's called recurrent neural networks. This is again very complex architecture. While I'm not going to get into that, I'll give you an example of like you have the chatbot. So when you open any website, you will have a chatbot which says, "How can I help you?" So that is done using the recursive neural networks architecture, right? RNN, right? It's a very fantastic sort of architecture. But just to give a idea, so you have got ANN, CNN, RNN, and these are the main three neural networks. And there's a lot of new things which are coming up. But I just wanted to give you a hint or a gist of how AI has evolved right from the expert systems to what we are today. Okay. Some of the examples of machine learning, very important. Okay. The way I start off is the most glaring example is Google search. We all do Google search day in and day out, right? Now, Google search in the background uses a machine learning algorithm. So typically, when you do a search based on a historic searches, the machine learning algorithm is able to come out with some pattern, and then it will try to give you some predicted searches on its own. Okay, which will be in line with your earlier searches, right? So that is one of the various examples of that we use machine learning algorithms. Medical diagnostics, if I see, I think somebody was talking about cancer diseases, right? Prediction of cancer disease. So today, there is a lot of historic data of patients which are captured, and the machines based on the historic data are trained to tell you whether a person has got cancer or is not having cancer, right? So again, there are algorithms. You have historic data, and you can use algorithms to predict whether a person is having cancer or not, right? So medical diagnosis is very important. Another way is chatbot. I told you. Then you talk about the movie recommendations. Very classical example. You go to Netflix, you go to Flipkart, you buy a product, you buy a movie. They recommend you some movies. They recommend you some products. From where does the recommendation come? So that recommendation is coming through a machine learning algorithm which is running in the background, because it is able to predict the movies that you're likely to see based on a historic data, also based on your profile. If there are some other people similar profile like yours he have seen other set of movies, then it can also suggest some movies. So it's all about uh, recommendation. So there's a recommendation engine which helps you to do the prediction on its own, right? So that is one example of machine learning. All these Alexas, then the Google Echo, all these machines learn on machine learning, work on machine learning, right? Alexa, if you see, Alexa works on the principle of now it has got its own machine learning algorithms, but as you speak and talk to Alexa, initially, the Alexa has to get tuned to your voice, right? So you initially train the Alexa with your voice, and as Alexa learns, it understands your voice, and then it is able to comprehend your voice and execute commands, right, based on whatever you ask, right? So those are some of the machine learning algorithms. The spam mail, to identify a spam mail or not, okay, you can based on the historic data, you have machine learning algorithm which can predict whether a mail can be a spam or the mail can be a normal mail, right? In financial, you talk about fraud detection. So if I have a banking transaction, which I do, and the bank catches you, all the banks capture your daily transactions. And typically, when you do a transaction, and there is a transaction where you generally you deposit 50,000 a month or 170,000 a month, but suddenly I see there is a figure of 3 lakhs or 10 lakhs deposit in a month. Okay, so that's a question which I need, as a banker, I need to know from where this is money coming. So there are ways for me to identify whether it's a fraudulent transaction or whether it is a normal transaction, right? So there are n number of examples of machine learnings. You talk about retail industry, you talk about manufacturing industry. Manufacturing industry, if I have a product which is defective, then I am able to, for new set of data, which new set of images, I can find out whether the product is defect or not, because the machine has been trained to basically to detect whether a particular image is defective, a product is defective or not defective, right? So these are various such examples. Any questions at this point of time? Any suggestions? Anybody wants to share something from an application perspective also? Okay. Fine. So now you guys have understood this. Some of the tools that are very popularly used. One is the two main important platforms that is mainly used in industry is one obviously the language that we use is Python. And the second language which is also used is R, and R is typically used in research organizations. A lot of research institutes use R, and not a lot of commercial organizations use Python. But there are other companies like SAS, SPSS who have their own platforms for writing machine learning programs. You have various interactive environments. Okay, you have got PyTorch, you got MATLAB, you have got Python Spider, you have got RStudio, you have got Jupyter Notebook. These are various platform environments where you can execute machine learning. Google Labs, Google Colabs is another environment. Is again it's a web-based environment where you can execute Python scripts, right? So these are some of the various platforms, and typically, if you have heard of Anaconda Navigator, right? Anaconda Navigator is one of the open source platforms, and if you install Anaconda Navigator, you will be getting RStudio, you will get Jupyter Notebook, and you also get Spider inbuilt in that particular application, and you can use those for writing in your either Python or R programs, right? Yeah, so for my today's assignment that I'm going to show you today and tomorrow, I'll be showing it on Python Spider, right? So to install, either you install Python Spider individually, or I've always recommended people to install Anaconda Navigator, right? And it's a free source available, and you can go to the internet and you can just download 16-bit, 32-bit, whether it's a Windows platform or it is a Mac platform or whether it's a Linux platform. Based on the platform, you can do the installation, right? Now, let me go through some of the examples of machine learning types. Now, what does equation y equal to mx plus c mean? Have you already heard this, all this in algebra? So what does y equal to mx plus c signify? Hello, am I audible?
Yes, sir.
Yes, sir. Audible, sir.
Okay, so what does this y equal to mx plus c denote? We have learned this in our, I think, early college days in the 11th, 12th, I don't remember when. It's quite some time, but yes, I mean, we have all learned this. You have an x-axis, you have a y-axis, you draw a line y equal to mx plus c. What is that line? So how will the line look like?
It's a straight line, sir, using the slope.
Correct. So it is a straight line, right? So if you have a straight line, typically you will have an x-axis, you have a y-axis, and you have a slope. And the slope will decide whether the y increases with x or y decreases with x, right? Now, in this case, y is, I don't know why so much of echo is coming. Can somebody go on mute? Hello? 1 minute. Okay. So when x increases, your y also increases. I'm still getting an echo. Uh, Ma'am, can you just check if everybody is on muted? Hello? is this noise? But why this noise is coming? I'm able to hear my own voice. Uh, okay, let me go ahead. It's not going to help. So when we talk about the straight line, are you guys able to hear my own echo?
No, sir.
You're not able to hear, no? You're okay. Okay. So when x increases, your y also increases, correct? Now, typically what happens, a y, we call it a continuous variable. Why is it a continuous variable? Because whenever the x increases, the y also increases. Let's take an example, a live example. So our x is, for example, years of experience of a person in the industry, and y is the salary of the person. Typically what happens is that as your years of experience increases, your salary also increases, right? So as your years of experience increases, what happens? You get promotions, you get incentives. Okay, so your salary also tends to increase. So years of experience is, if you plot it on the x-axis and salary you plot it on the y-axis, so you will get a straight line. Sort of a straight line because it is more or less linear. Okay. Now, if you look at this equation y equal to mx plus c, now I'm just trying to put it in the form of some notations. Y called the output. It is also called a dependent variable, right? Because y depends on x doesn't depend on y. Your years of experience does not depend on salary, but the salary depends on years of experience. Okay, so y becomes a dependent variable. X, we call it an input. We also call an independent variable, and sometimes it is also called a feature, and it is also called a predictor. Okay, these are various terms that we use in the industry: feature or the predictor. And M is called coefficient. Okay, that's how we use when we go to machine learning data science. When we use these terms, we have to use dependent variable, independent variable, and we also use something what is called the coefficient. Now, this y equal to mx plus c is having one independent variable, right? So this sort of equation is called univariate regression. Univariate, sorry, univariate IAT regression. Univariate regression. You could also have a multivariate regression where you have one output, but you could have multiple independent variables, m1 x2 plus m2 x2 plus m3 x3 and so on. They are called multivariate regression. And somebody think about a live example of multivariate regression? I give an example of univariate where like years of experience and salary. Can somebody give me an example of a multivariate regression? Whatever can come in, whatever comes in your mind. Anybody? Multivariate regression.
Price of the gold, sir. Day-to-day price.
Very good. So your price of the gold depends on what? The price of the gold is what? Y or X?
Why, sir?
Very good. So what are the X1, X2, X3?
Maybe stock exchanges or Any wars in
So yeah, it could be depending on what, depend on the economy, some indicator, right? Some economic, I'm not economist, but say it depends on some economic indicator. Okay. It could also depend on the demand supply, the what you call it, the demand supply indicator, right? Maybe some indicator, right? Okay. So you could have multiple variables, indicators or features which indicate or which will decide or which will have an impact on the price of gold. I give a very simple example. Let's say price of a house. And price of a house is a dependent variable. Price of a house can depend on what? Number of rooms, it could be x1. Square feet of the house, which could be x2. Third could be in which floor you are residing, x3. Age of the house, whether it's a new construction or an old construction, that also has. Proximity to the mall, x5. So on. I mean, you could have so many parameters or features which would reflect the price of a house, right? So this is an example of a multivariate regression. Okay, so you have a univariate regression, you have a multivariate regression, right? The second type, what happens if I got y equal to mx plus c? The difference here is that y is a discrete variable. When I say discrete means it has got only fixed set of values. That means either 0 or 1, or it could be, if it's an image, could be dog, cat, or horse, or 1 to 9 if it's a range of values, so on. So whenever there is a discrete set of values, that is, there's a discrete only fixed set of values. Okay. In the case of regression, what happened was your y was a continuous variable, because as your x increases, the y was also increasing or decreasing. So it was not having a fixed set of values, it was having a different set of values. But whenever your y is a discrete, it is called classification. So if you are talking about regression and classification, so regression is where you have continuous variable, but you have an output, you have a series of inputs. Classification also, you have an output, series of inputs, but the only difference here, your y is having a discrete set of values. And this regression and classification, if I combine it, it is called a supervised model. Okay, so you'll have a data, either it could be of a classification type or you could have a regression type, and then you will use supervised models or algorithms to basically, those algorithms will read those data, historic data, and try to derive a pattern and do some prediction. That's where I'm coming back to machine learning. So now basically I'm talking about a supervised model where you have an output, you have a set of inputs, and you have regression and classification. Any questions on regression classification? Anybody? Have you understood what is regression? What is classification? Is it clear to all?
clear, sir?
Okay. The next part is the unsupervised model. Now, our scope for these 2 days is on supervised model only. Okay, so but I'll explain you what is unsupervised model with an example. So while the supervised model, you have an output, your set of input. So you know that there is an output and a series of input, and so you know that there is a pattern out of the data because you know the y and you know the x, right? But sometimes you have data, but there is no y, there is no x. You have set of data, there is no particular output variable, there is no particular set of input variables. And then you have to derive some patterns out of the data, right? So you have to, there will be some hidden pattern which you need to derive, correct? So in order to do that, you have to use a separate another mechanism, and I will explain that with the example. I am a mall owner, and as a mall owner, I want to find out the behavior of my various customers who come to the mall and buy products, right? And I want to formalize some strategy based on the demography of the person, based on the attributes of the person. Now, what are the attributes? I will decide what are the attributes. Now, so when I go to a mall, the mall owner is capturing the age of the person, the salary of the person, and then typically based on the number of products a person buys on a monthly basis, daily basis, weekly basis, so on, I will come out with some sort of a formula which will reflect the spending power of the person. The higher the spending power, guy is very lavish, he likes to spend a lot. A moderate person could be somebody who is very cautious, and somebody who is maybe, so you have a spending power from 0 to 100, and you could have, I could say that above 80 is someone who is very lavish, 40 to 80 is moderate, and 0 to 40 would be conservative, right? Okay, so I capture for my various customers, I capture age, salary, and spending power. And then what I do is I split this data based on some common attribute. Now, the how many attributes I make is depend on what I want to achieve, right? So if I want to focus on people who are spending, I want to come out with some strategy for people who are very high salary, but they don't spend much, for example. That's my, I want to come out with a strategy. So what I'll do is I will split this data into various types. I could have one type is high salary, high spending power. Second is high salary, low spending power. And third could be low salary, sorry. Third could be low salary, low spending power, high spending power. That means the guy he spends a lot in spite of low salary, but he takes a lot on credit probably. He takes a lot on credit card and all that. So I do the splitting of my data based on these common three attributes. Based on this splitting, then the algorithm will try to derive some sort of relationship, or will try to bifurcate, bring the data or split, divide the data in such a way that it will be able to tell me that maybe what is the percentage of people in category 1, that is this one, this is category 1, category 2, category 3, percentage of people in category 2, and percentage of people in category 3. Okay. So based on this, if I know that, okay, maybe 30% are in category 1 and 40% in category 2, for example, and 30% category 3, or maybe 20%, and remaining could be in others. Okay. So based on my, if I want to focus on this category 2, I see there are 40% people. So for this 40% customers, I can come out which are high salary, low spending power. I can basically, they are having high salary, but they don't spend much. So I can come out with some promotional campaign. I come with some advertising. I come out with some buy one get one free option and so on, right? So my idea is to increase my revenue for these low people, right? Because ultimately, as a mall owner, I want to increase my revenue, right? So I need to focus on this and try to come up with a strategy. So in order to do that, I do this breakup, and this sort of breakup, I call it clustering. I call it clustering in machine learning. Right? So when I talk of unsupervised model, I use what is called clustering, where I group the data into some common attributes and then derive some pattern. And the second is the learning association. Now, this learning association is the classical example we talked about, the recommender system, right? The movie recommendations and the product recommendations, they all worked on an unsupervised model. So we use an unsupervised algorithm to basically do the recommendation, right? So in supervised model, we talked about regression and classification. In unsupervised model, we talked about clustering, and we also talked about learning association. Okay. And the third important one is the reinforcement learning. Now, this is something, again, is a very advanced algorithms. I'll not touch upon this now, but I will just give you a gist how it works. Okay. So typically, when I look at a robot is a great example of reinforcement learning. Okay. Now, when a robot, you have a robot which is a mechanical robot. So you first of all you have to look at the mechanical aspect of it, and then once the robot is ready, is designed, then you have to train the robot to do a particular set of actions. So the robot has to either pick up a particular in an operation floor. It has to pick up a raw material and put it in some place, right? So it has to be trained, okay, to do a particular set of action. So when the robot, as it learns, right? So you have something called an state and an action. So what happens is, as a robot moves from one state to another state using an action, so when the robot moves from one state using an action, if the robot acts in a way so that it try to reaches the desired goal, it gets a positive reward. Similarly, when it moves to another state, but it doesn't reach the desired goal, but the action does not lead to the desired goal, then it gets a negative reward. So at every instant, the robot is learning, relearning, and every time as it moves from one state to another, either it gets a positive reward and a negative reward. So the objective of reinforcement learning is, so robot becomes, when the robot is, we can try to maximize the number of positive rewards. That means the robot is trying to go to the desired destination. Right. So that's again a very complex algorithm, but the concept is all about how you can move a robot from one state to another, and based on that, he gets a positive or a negative reward, right? So that's all about reinforcement learning. So if you look at the self-driving cars of Elon Musk, right, you know, he's a pioneer. And when the self-driving cars when it goes through a training, right? So you have got, it goes to a particular path, right? And as it goes to a particular path, when it, so it is trained to move in a particular path. So if it as it learns, if it falls into a pit, then it gets a negative reward. Okay. If it moves toward the desired action, then it gets a positive reward, right? So every time it moves in such a way, it is trained, so that ultimately it moves to a trajectory where it is the maximum rewards. Okay, that's how the machine gets trained. And then when the self-driving cars, if you see how a self-driving car works, it basically has cameras, it has got GPS, it has got sensors. Okay, so when you talk of self-driving cars, it uses a combination of supervised model as well as it uses a combination of reinforcement learning, right? Why supervised model is basically when you take a camera, when you have a camera, right, on the self-driving cars, and you have a traffic light, right? So when you have the traffic light, it captures. So using images, it will be able to capture whether the image is green, red, or yellow, and based on that, it can take an action, right? Or if it tries to detect an object in front of you, so using again using a detection mechanism, it should be able, the sensors should be able to detect whether there is a person in front of in the car, so that it has to stop or it has to continue, right? So there is again a very complex algorithm used for writing a self-driving car. But what I'm trying to bring is a hybrid model of supervised as well as reinforcement learning. So any application need not be totally only supervised or only unsupervised or only super unsupervised only reinforcement. It could be a combination of any of those, right? So typically there are three types. So one is called the regression classification, which is supervised model, unsupervised model, which we talked about learning association and clustering, and we also talked about reinforcement learning, right? So these are the three mainly machine learning types. Any questions at this point of time? Can I get a quick yes or no on the screen on the chat board? Okay. So I'm presuming everything is fine. Okay. Please ask a question if you get stuck. Now I'm going to go through one very important slide, and this is where I require all of you to understand what is the model workflow. Hmm? Okay, so let me come back here. Please pay attention to this. I'll go very slowly, but this has to be understood by all of you. If you understand this, then it will be easy for you to understand the code which I'm going to show you later, right? So first of all, imagine that let's take the example of years of experience and salary. This is my data, right? Now this data I is basically belongs to the HR department of a company. So the HR department will have the years of experience and salary of all the employees in the organization, right? Now the HR manager has come to me as I'm a data scientist, and the HR manager tells me that can you come out with a machine learning model which will be able to predict, do a proper prediction for this data. Because what the HR manager wants, that once I have a model in place, the HR manager just enters the years of experience, the model should be able to give me an accurate or more, at least close to accurate salary. Okay, so that I can send an appointment letter to the candidate. Okay. Okay. So now I'm the data scientist. I get these records, and imagine that there are some 1,000 records. These are all historic data. Now what I need to do? I need to of course train the machine, as I told you, train the machine, and the machine should be able to come out with some pattern. Now before that, when I get the data is always not in the best format. So I need to first do some sort of a data pre-processing. Also call it as a data preparation phase. So what I do in data process, once I get the data, I could have situations where the data is missing. Means I may have years of experience, I may not have salary, or I may have salary, but I don't have the years of experience. Okay. Or I may have total blank data. There are some blank rows. Typically, the client will give me an Excel format or the file in some Excel format. So I'll have to really go through the data. So I'll have some lot of missing data. I'll have some missing values. I may also have something called outliers. Now, what is an outlier? I could have data, for example, if my working age is from 21 to 60, right? That's my years of experience could be, sorry, 1 to say 40, because my working age will be typically 21 to 60. I'm only talking about working age. So it's 1 to 40 years of experience, right? But I may have some data which is showing 70 years of experience. I may have data which is showing me a salary of 100 rupees, or I may have salary which which is 1,000 rupees, because my minimum salary is maybe 2 lakh or 3 lakhs a month, a year, for example. But that means I will at least earn 20,000 a month or 30,000 a month, right? But if I get something like 100 rupees, 200 rupees, which is obviously incorrect, right? It doesn't make sense to me. So such sort of data needs to be taken care of. And as a part of data pre-processing phase, you need to eliminate all such outliers. You need to take care of missing data. Means you have to fill up all the missing values. You need to take care of null values and so on. Now, when you do this data pre-processing, as a data scientist, you have to ensure that all these abnormalities are removed. And to do that, what is very important, if you have some missing data or if you have outliers, you have to go back to your customer and tell the customer, I have some wrong data. Please provide me the correct data. See, if I don't have the correct data, my model is going to give me incorrect results. So you have to ensure that before you train the machine, you have to correct and pre-process the data. And this is where you do maximum coordination with the client, because the responsibility of the data is not with you as a data scientist. The responsibility data lies with the client. So the client has to give you the correct data so that you can come out with a effective model. So imagine that you have taken care of all such things. Always remember one thing, whenever you have some 1,000 records, in this case, for example, and if you see some missing data, I don't have missing value, I have some missing values, please never delete any data. Never. That is the last option. Because if you have less amount of data, you have less amount of data for training. As I said, more the data is given to the machine will learn through experience and come out with a better prediction. So if you delete some data and reduce the data, is not going to help. So the last option should be to delete. Always try to preserve the data unless data is really bad and there is no other option, then you have to delete it, right? Okay. So now you have done the data pre-processing, and the next thing what you have to do, once your data is clean, you're taking care of missing data, you're taking care of outliers, you're taking care of null values. I will split the data into training set and test set. This is very important. You have to split the data into training set and test. And why this is required? As I said, if you remember by machine learning definition, if I go back, I had very clearly mentioned machine will learn and try to derive a pattern out of the data. So for this, you use the training set. That means out of the total data, typically training set is not less than 70%. And test set should be not more than 30%. So if my total records is 1,000, at least 700 records should be training and 300 records the test. Now, so this training set is used for training the machine. So this 700 records, if I'm taking 10,000, 1000. So 70% of that I will use for training the machine and try to come out with a pattern. Now, once I've come out with a pattern, then I will need to predict the output for any new set of input data. Now, this new set of input data, which has not been used for training, is my test set. And the test set is especially used to find out whether the model is accurate. The model is giving me a right prediction or an accurate prediction. As I told you, you cannot get 100% prediction. But in the industry today, if I have an accuracy of 85% plus, I can always say that the model is good. So my model should be such that it will be able to predict an output based on the learning it has got from the training set. So this estimation or the calculating the accuracy of the model is done with the test set, while the training is done with the training set. That's why you need to have a training set and you have a test set. Okay. Now, so now imagine that I have out of 1,700 records my training and 300 records are my test. And this is training. Okay, now what I do? I have completed my data preparation phase. The next thing I will go to the model training. What I do, I take the 700 records of the training set. That means I take the dependent and the independent variable. In this case, salary is my dependent variable and years of experience, as we discussed earlier, is my independent variable, IDV. Okay. I take the 700 records, I feed both the dependent variable and independent variable, and using an algorithm, I will use a regression algorithm because I have this is a regression data, right? So what I will do is I will try to derive a pattern. When I say pattern, I will try to derive a relationship between years of experience I'll write between DV and IDV, independent variable and dependent variable, right? So those 700 records, what I do, I use that 700 records as a training data. Okay, I feed into a machine using an algorithm. I try to derive a pattern out of it. Once the machine has learned how to derive a pattern, I take the remaining 300 records of the test set. And what I do, I take the independent variable of the 300 records. What is the independent variable? The years of experience. This 300 records I feed into the model. Now here my model is ready. This is my model because based on my training, my model is ready. I take the independent variable of the 300 records, feed into the model. Now, since my model has, based on the 700 records it has got trained, it has sort of come out with a pattern or relationship between the independent variables and the dependent variable. It will come out with a predicted salary. Please see that I have not touched the actual salary for the test data. I have not touched the historic data. I have not touched the salary. This is my 1,000 historic data. So for the 300 records, I have not touched the salary yet, actual salary. I have only captured the years of experience, which is my independent variable. I feed into the model, and since the model has learned through past experience, it has come out with some prediction. It will come out with a predicted salary. For the 300 records, it will try to come out with a predicted salary. Then what I will do is I will compare the predicted salary which have come out from the model with the actual salary, which is for my test data. Actual salary of the test data, because the historic data I have got the salary for the test data also, but I had not touched that when I tested the model. I took the independent variable of the test data only. Independent variable is years of experience, and based on the pattern, based on the learning the machine has learned, it will be able to come out with their own pattern for the new set of test data, for the test data. And that test data, based once you feed the years of experience, it came out with a predicted salary. And that predicted salary I compare with the actual salary of the test data. And if my predicted salary is close to the actual salary, then I say that my model is efficient and I can propose the model to my client, or I can deploy the model to the customer, for the customer. Is this clear to, and if obviously the actual value and the predicted value does not close, that means I have to relook at some other models for running that particular data set, because that particular model is not giving me a good accuracy. Is this workflow clear to all? Have you guys understood this this machine learning workflow? Very, very important. Can I get a quick yes or no on the screen? I need to get an answer on this. Yes, Shanti, Asha, others, have you guys understood? I need a yes or no on the chat box.
Yes, sir.
Who was that, Rohit? Others, have you understood? I'll pause for 30 seconds. If you don't understand this, then it will be difficult for you to appreciate whatever I'm going to teach in the future. So please take out time and run through whatever I've taught you. And if you have any doubt any time, just tell me, I will repeat it. But this is the crux. Okay. Now that you have understood this concept, let me just save this so that I can use it later. Okay. Now that you have understood this, I'll go back to my this. Okay. So let's start off with, now we know the data preparation phase or the data preprocessing. We have that, then we train the model, then we test the model, or we also call the model evaluation, and then we deploy the model for the customer location. That's the general 4 phases we do. The first phase, which is the data preprocessing phase, as I said, it needs to be done to take care of all abnormalities in the data. Okay, and obviously data preprocessing, besides this, you have to do some certain steps. So the various steps when you write any code as part of data preprocessing in Python, these are the following things you need to do. First of all, you need to obviously import the library. So there are some few important libraries. Uh, I'm not sure how many of you know Python. If you know Python, very good. If you are not knowing Python, then take, I mean, you should do some crash course on Python, because this is where I'm going to use Python, right? So you need to have some good knowledge on Python. Otherwise, if you, I mean, many of you, if you, even if you know Java, you can probably understand what I'm doing. But yes, knowledge of Python is very important. So you should always take it up if you don't know it. And many of the colleges have in their curriculum. Okay. So the first important thing you have to do is import some few libraries. And there are very important libraries you need to use for executing any Python scripts, which I'll come to that. Then whatever historic data I have, I need to import it into my system, because I need to first train the model, train the machine with that historic data. So that historic data, I have to import the data set. So there are libraries to import the data set. The data set could be an Excel file, could be a text file, could be a CSV comma separated file, or it could also be a PDF file, whatever. So once you imported the file, then you have to identify which is your dependent variable and which is your independent variables. Please note that here I'm talking about supervised model, there will be always one output or one dependent variable, but there could be one or more independent variables. Please understand that. There will be always one output variable, but there could be one or more input variables, or what are called features or predictors, which I told you, right? So I have to import the data set and identify the independent and dependent variable. Third, if there is some missing data, how to take care of missing data, I will show you. I will get an example. Categorizing data is another example, another pre-processing step we have to do. Fifth, splitting the data into training and test set, which I already explained to you as a part of the workflow. You always need to split the data. One is for training and one is for testing the accuracy of the model, right? And the last part is feature scaling, which is again one of the very important pre-processing steps you need to do on your data before you get into the modeling, or you train the model, before you train the model. Now at this point of time, I will go back. Now I'm opening Python Spider. This is what your Spider is. I'm not sure how many of you are aware, but as I said, if you Spider, this is your icon for Spider. And as I said, if you have Anaconda Navigator, it is already inbuilt as part of that, right? Now, I'm going to give you all the data sets after the session tomorrow to your HOD sir, and he will forward it to you. For now, what I'm doing, I'm going to, sorry, your institute is PSCMR, okay? So when I give you a zip file, you'll have three subfolders like this: data preprocessing, regression, and classification. Okay, so you have to select the data preprocessing folder, again data preprocessing folder, and I say select folder. So this is the folder I'm in. This is my path. Left hand side is what is the where I'm going to write code. Now the code is already there, so any code you're going to write, it should be on the left hand side here. And typically all the files with ending with .py is a Python script, is a Python file, right? On the right hand side top, you'll see three tabs: help, variable explorer, and file. So help is if you want to get any help on any documentation, that's where you use the help. Variable explorer, so when you execute any command and you assign to any output variable, the value of the variable you can see under variable explorer, right? And file says all the files which are residing in this particular folder that we selected using the browsing path. Okay. Now for this example, I'm going to use a file called data preprocessing template.py. I'll double click. Okay, this is my file, right? And the input data file I'm going to use is data.csv. This is my input file, historic data file. Now this historic data file has got 4 columns: country, of the country, age, salary, and whether a person is going to buy a car or not going to buy a car. So typically, imagine that I'm an automotive company and I'm doing a survey of a person likely to buy a particular brand of car or not. So I capture the country to where the person belongs, the age of the person, the salary of the person, and there's an indicator whether somebody is going to buy a car or not going to buy a car. Okay, and this is data which I get as a data scientist, and I want to come out with a model to predict whether a person is likely to buy my car or not going to buy my car using a machine learning model. So as a first step, I have to do my data preprocessing, right? Now, before I do that, can somebody tell me what sort of data is this? Is this a regression data? Is this a unsupervised data or is this a classification data? Anybody? What sort of data is this?
Classification data, sir.
Why?
Because the class labels are divided into two categories, which is discrete. So
Very good. Very
it
nice.
comes under classification.
Your good name?
Shanti, sir.
Shanti. Very good. Absolutely right. So in this case, it's a classification data because you have a label data which is discrete, the yes or no. Okay, because you want to analyze whether you're going to somebody is going to buy a car or not. So your dependent variable is going to be purchased, yes or no. And your independent variables are going to be country, age, and salary. Okay. So what I will do first, I will go to my first. Okay, the three important libraries that you need to know is one is NumPy, which is typically used for numeric calculations, all your building arrays, all that is done using NumPy. Then you have Pandas, which is used for importing data sets. So all your historic data that you're going to import, you have to import using Pandas. And you have what is called the matplotlib.pyplot, which is mainly used for any graphical representation that you do. I'll show you some examples. But these are the three minimum libraries which you always need to use whenever you're writing a Python machine learning program. Can you mute this person, please? Okay. So these are the three important libraries which are very, very important, which is required, right? Now, this is an example of importing the data set where you have data set pd.csv using pandas library, and this is the data set. Now, let me see, and you have to identify your independent and dependent variables. So typically, we use X capital to identify independent variable and small y to capital capture a dependent variable. And please note, in Python, variables are case sensitive, so be careful with the case because X and small x and capital X have got different meanings. Okay, now I don't know. Can somebody tell me what does this mean? I'm identifying the independent variable. What does colon comma colon minus one mean? Anybody? Can anybody tell me what is colon comma colon minus one? Have you guys learned Python? Shanti, have you learned Python? Has your batch learned Python?
First column represents all rows.
Colon comma represents all rows. Okay.
And second column represents all columns except last column.
Very good. So you guys have learned Python or no in your syllabus?
We have, sir.
You have, right? Okay. So that's good. And what does comma 3 mean?
All rows and fourth column, sir.
Fourth column. Very good. Right. So all rows were the fourth column. Okay. So you guys know Python. So that's fine. Okay. So what I'm going to do now is that, see, on the bottom, I have got the console. And this is where I'm going to execute the command. I can see the output here. And if there's an error also will come here. Okay. So as a part of data preprocessing step, I will first import my library. So typically I can execute the full command together, but for just for explanation purpose, I will take single line and do control and enter to I will execute the line, and if when it executes with a without an error, it doesn't give you an error message and it comes to the next prompt. I'll import matplotlib and I'll import pandas. Okay, I bought the 3 important libraries. Then I import my data set, and if I want to see my data set, I can go to Variable Explorer. I have a data set which is of a type data frame, and it says there are 10 rows and 4 columns. Okay, 10 rows and 4 columns. So this is my data set, and it has got my country, age, salary, and purchase, yes or no. Is there any problem with this data set? Is there any problem with this data set?
It has null values, sir.
Okay, good. It has got null. So what do you do, Shanti, as a data scientist? You got this data from the client, correct? And what will you do?
Replace those null values using mean or median or mode, sir.
But why are you going to do that? What did I tell in the beginning? If you have missing data, what you should do? You see, mean median mode is a good thing, but you cannot do anything on your own. You have to first go to the client who is responsible for the data, not you as a data scientist. You cannot make any assumptions unless it's really required. So you have to go back to the client and ask for the missing data. And in the worst scenario, if you don't have any data, if the client says, okay, I don't have the data, you make some assumptions. Then you can look at coming out with your own assumptions. So Shanti, whatever you're saying is the last step. Is it clear?
Okay, sir.
Always, guys, remember you are not responsible for the data. It's the client. So if there's something wrong with the data, please don't make any assumptions right in the beginning. We all tend to do that because we want to do everything in a hurry. So let's fill up the missing value and start doing the modeling, right? No, that's not the way it is. You should always ensure that you have the correct data, and that data should first come from the client. But yes, if the worst scenario doesn't happen, then you have to make some assumption, because as I said, 2 things you should do. One is you should take care of the missing data, and second you should not do is delete the data. I could have deleted the row where there is a NN value. So my number of records have gone down to 8 from 10, and I would have been happy. Chalo, I don't have anything, no problems. I can just work with 8 data. But as I said, less number of data, the model will be, the accuracy will be less compared to if you were to train the machine with more amount of data, right? Okay. Now in this case, what is the client doesn't have the data. So what client says that I don't have the data. So client says make some assumptions. So as Shanti said, we can do something. One more thing, guys, I want to tell you. If you want to really take data science as part of your career, you need to have a very strong statistical foundation. If you're not strong, if you don't know statistics, please do a crash course on statistics. Whether you do it online, offline, it's up to you. But if you don't understand mean, median, mode, if you don't understand variance, standard deviation, it will be very difficult. So please keep in mind, because all models you are built in machine learning is all using statistics. Everything is statistical based. Okay, so you have to make sure that you have very strong foundation of statistics. Good. So now, having said that, now in this case, what I can do, what I will do is I will take the mean of the salary, put in the missing value. I will take the mean of the age and put in the missing value. It's a very simple example, right? And then I will try to fill up the missing data. Now, before that, what I will do is I will assign the independent variable. So my independent variable is country, age, and salary. And then I have got the dependent variable. So what is the dependent variable? So the dependent variable is yes or no, right? So I've identified and I have the independent variables and I've identified the dependent variable. Then here I'm going to use the strategy mean. I could have used median, I could have used mode, but for now I will use mean, and I will going to share this code with all of you. So I'm just executing this for the age and salary field columns. And now if I see the value of age, sorry, I see the value of X. So I've got replaced it by the mean. I replace it by the mean, right? So once I've taken care of the missing values, so I've got all, assuming that I've taken care of outliers, missing value, and this. The next step is, now the point is, can I use my data set, write it for modeling? No. If I see my data, there are some text values. So I've got two fields which has got text values. One is country and one is purchased. One thing all of us need to know, all machine learning algorithms take numbers as parameters. Machine learning algorithms don't understand text, right? It only understands numbers. So you need to convert all the text that you're going for analysis, you're going to do analysis into a numeric format, or you may call it a binary format, whatever. So there are two fields we need to do that. One is a country field and the other one is the purchase yes or no field, right? So what do? I use a process called data categorization. Okay. In data categorization, I use so there are two important functions in Python. One is called a label encoder and one is called a one statement. So I will explain to you what it happens. Suppose I have got a country, I've got three countries, India, US, UK. In my data set, I've got these three countries. Okay. So what first thing I have to do is I will basically convert this into serial numbers 0, 1, 2. So I create a serial number starting with 0. So if there are six countries, I have array 0 to 5, 7 countries 0 to 6, because in Python array starts from 0, right? So I will have three elements. I will have here in the case three values 0, 1, and 2. Okay. And then what I do is I will create an array. So whenever it's in India, I'll create an array of three variables. Why three? Because there are three values for country, India, US, and UK, unique values. So India, I will represent it as 1, 0, 0. US, I will represent it as 0, 1, 0. And UK, I represent it as 0, 0, and 1. So what I'm doing is I'm creating a sparse matrix where so all the values are zeros except for one value in the array, which will be one, which signifies that the country exists. Okay, so in one row you'll have only one country, so you'll have only one and other are zeros. Similarly, US will be 010, UK will be 001. Okay, so this is called an array of dummy variables. Dummy variables, right? Now this is done using one hot encoder. And this is done using label encoder. You have a label encoder function which converts into serial numbers, or in fact, it can also be used in the case of the text that is yes or no. We will use label encoder to convert into 0 and 1, because if it's a binary value, you can only directly use label encoder. So using label encoder, one encoder, you are basically converting a text into an array of dummy variables, and this process is called data categorization. So let me just show it to you on the screen. So I go back. This is my X field. So I am going to run the label encoder function, and I go to X. Now if you see that my country has been declared to 0 to 1. Now you don't have to really bother which is 0, 1 and 2. The algorithm takes care of that. I'm just trying to explain you the concept, and okay, so you don't really have to care how it is mapped internally. Now if I use the one hot encoder, now see what happens. You will see here there is a array of dummy variables 100, 001, 010, and so on. So this your country has been replaced by 3 columns, and then you have got age and salary. So what have we done? I have converted my country values into an array of dummy variables using one hot encoder. Okay. Similarly, where I have got y, I use the y label encoder to convert this into 0 and 1. Okay. So this is the process of data categorization of whatever non-numeric values are there. And if you're going to use that for analysis, it's a must that you have to use label encoder and one hot encoder to convert that into numeric or binary values. Is this clear to all of you? Any questions on this? Shanti?
Clear, sir.
Is this clear to all of you others? Anybody has any questions on this? Okay, what about Ravani and Rohit? Asha, have you guys understood? Can I get a quick yes or no on the screen? Okay. The next thing which I'm going to do, now I have got all my data which is in clean format. That means I've taken care of all the data cleaning. I've taken care of all the text fields which have been come number format. Now the next step I'll do is splitting my data into training and test set. And we know the reason why it is. So when I do the splitting into training and test set, so typically what will happen is that, okay, let me make this bigger so I can see it. So when I'm splitting my data, I split up into 4 variables. Xtrain, that is the training set for the independent variable. Xtest is the test set for the independent variable. Similarly, Y train and Y test. So I'll create 4 variables for the training and test set, independent and dependent variables. And then I used a test size equal to 0.2. Sorry, whatever test size I give here, which means 20% of my data is going to be training set and 80% is going to be test set. The parameter that I'm going to use is my test set parameter percentage and not the training set. So using this, what I'm doing, I'm creating 4 variables x train, x test, y train, y test, and using the train test split function or method, I use these are the various parameters. I split it into these 4 variables, right? Now, if you see x is now 10, 5 because initially you had 4 columns, 3 columns for x. Now it has become 5 columns because your country has got replaced by 3. You got 3 countries now, right? 3 dummy variables, right? And then you have got y, which is 1. And by default, if you see there's comma here means always it is one column, because as I said, there'll be only one independent variable. So I am going to do this. I am going to split this. And now if you see here, you have got x train, which is 8, because 80% of 10 is 8 and 20% of 10 is 2. So you got 2 records test set, 8 records training set. Similarly, x test is 2, 5, x train is 8, 5, x is 10, 5. Similarly, y test is 2 and y train is 8, right? So what I've done is I have split the data into training set and test set. Okay, is this clear to all of you? The most simple step. Any questions here on the splitting into training and test set? Shanti, are you clear?
Yes, sir.
Okay. Shanti, can you tell me what does this random state mean, if you have some idea?
Maybe the test samples are taken at random, sir.
Correct. So when you take random state 0, it will split it into first 8 and remaining 2. But I can have different random states. So it will create a random number, and based on the random number, it will select 80% as test training set and 20% a test set, right? So you can typically use random 0. I've seen people using random state 42. Okay, so we typically use random state equal to 0. Okay, so this covers the data split. The last most important step of data preprocessing is called feature scaling, and this is very, very important. If you don't do the feature scaling, your model efficiency really shoots up if you do the feature scaling. Now, why this is required? So let's take this example. We have got age and salary in our data. Now your age has got range from 21 to 60. And your salary has got range, say, from 10,000 per month. It could be even 1 crore a month or even 5 crores. If I'm a CEO of a company, I could even get up to 5 to 10 crores of a month, right? So see the range of my values. Age is 21 to 60, but my salary is 10,000 to 1 crore. And if I want to draw this in a plot and try to do some representation of age and salary in an axis in a graphical format, it will be very, very difficult because both of them are in different scales. So one of the best practices that we do is we use a process whereby you scale down these values so that both the variables are having a common base scale, and that will allow the machine learning algorithm to do a proper correlation between the two variables. This feature is called feature scaling. So when I'm saying feature scaling, scale down the features to a common base scale. Okay, and to do that, there are two main functions which we talk about. One is called standardization and one is called normalization. So there are two different functions which are used. So standardization uses x minus mean x divided by standard deviation, and normalization uses x minus mean x by max s minus mean x, right? So using this standardization and normalization process, so we use what is called the standard scalar function, which uses this, and min max scalar, which uses this normalization function, right? So using this, when we use the standard scalar and min max scalar, so you use this function on the x train and x test. And typically, once you do the feature scaling, the values, when they're brought down to a very small value, typically between -1 or +1 or -2 and +2. And then again, you as a data scientist, you may go and understand, go into the depth of how these functions have been written, but you don't, I mean, if you're not really are not so keen to get into a depth, you don't have to really bother how the mapping is done from the larger value to smaller value. That is taken care by this standard scalar and min-max scalar function. These are standard Python functions which are available. But the essence you should understand, you have to do feature scaling because you have the variables in different scales. And when you have different scales, you need to do min-max scalar or standard scalar function to bring it to a common base scale. Okay, so let me go back and before that, okay, now if I see x train here, these are my 8 values, and x test, these are the 2 values. Okay, so 8 records and 2 records. Now what I'll do is I can use either standard scalar or min-max scalar. Both are used in the industry, but generally I've seen people use standard scalar more, but it doesn't matter. You can use either of them. That is. So for now, I will use standard scalar. So what I'm doing, I'm using standard scalar on both x train and x test. Now see the values when I use the standard scalar function. After I run this, so if I see x train, my x train, see the values now it has become 2.64, minus 0.774, 0.263, 0.12. See the values are scaled down. What was earlier, see here, x test, x train was this. Now see after scaling down, it becomes like this. Now then, okay, so you don't have to bother how it is done, the mapping is done, but see the value is scaled down. Similarly, if I go to x test, the values again it is very small, minus 0.72, 0.6, and so on. So whenever you have numeric features in your data set, always remember that you should always do feature scale. And that really optimizes your model efficiency. That's one of the best practices we use today in the industry. So if I have to recap the data preprocessing steps, so we started importing the libraries, importing the data set, identifying the independent and dependent variables. Please be aware of the case. We took an example of missing data, but first thing, as I said, go to the client and get the data and never delete any data. Then we do the label and hot encoder to convert text into binary numbers. This we use for X and this we use for Y. Then we did the split using test size parameters. So you split into 4 variables, X train, X test, Y train, Y test. And finally, what did we do? Either min-max scalar and max standard scalar. Using feature scaling features, we scale down the value to a common base scale so that a machine learning algorithm be able to analyze or do a proper correlation between the variables. So that covers our data preprocessing phase. We will start with regression and classification with some examples tomorrow. Okay, and tomorrow I would like all of us to assemble at 1:45. Is that okay for all of you? Is 1:45 okay for all of you?
Yes, sir.
Okay, so we'll assemble tomorrow at 1:45. Before that, any questions? I will pause for 30 seconds. Anybody has any questions till now? Shanti, you have any questions?
No, sir.
What about others? Rohit? I mean, have you guys, are you making any sense? Am I going at the right pace? Is it okay, Shanti?
Yes, sir. It's very clear.
Okay. So, guys, please interrupt if you have any questions because I'm assuming that you have understood because when I start tomorrow and I start executing all this workflow, everything should be clear in your mind. Okay. So that you'll be able to appreciate once I execute this code in front of you. Okay, great guys. So I think thank you very much and we will meet tomorrow at 1:45. I think the Google Meet link should be the same. We will join this. Ma'am, is the link the same for tomorrow? Okay, I'm presuming it is going to be the same. I'm not sure whether she is there or not. Anyways, guys, so we'll meet tomorrow at 1:45. Okay, and we'll continue with our session. Okay, thank you very much. Bye bye.